Welcome to Mrs. Z's Chemistry. In this video, we will talk about 2.3, atomic structure and symbolism. So here is a good scale of how the atom is structured. We have the nucleus at the very center where the protons and the neutrons are. And then in the region of space surrounding the nucleus, we have all of the electrons. For scale, think about a football stadium, where the outer edge is the outer edge of the atom. At this size, the nucleus would be the size of one single blueberry at the very center of the football stadium. At this scale, an electron would barely be visible. So imagine the tiniest speck of dust that you can, and you've got a few specks of dust floating around in that huge football stadium, and those are the electrons. This chart shows all of the specks of the electron, protons, and neutrons. The electrons have a -1 charge, protons a +1 charge, and neutrons are neutral. This far right-hand column over here can show the protons and neutrons mass in grams. You can see that the protons and neutrons are roughly the same size or same mass, 1.67 something times 10 to the -24 grams. And then the electrons are about 1,500 times smaller. On the back of your periodic table, we have this box called the atomic structure box. And we can look at the symbol in this format here, where X represents the element symbol found from the periodic table. A equals mass number, where mass number is equal to protons plus neutrons. Mass number must always be a whole number because you cannot have a partial proton or a partial neutron. Mass number is not shown on the periodic table. The masses on the periodic table are not mass numbers. They are something a little bit different that we'll learn in a little bit. Z is the atomic number, and that is the number of protons. On the periodic table, you'll find this number in the upper right-hand or left-hand corner, and it's the number of protons that a certain element has. So written in this format, you've got the element symbol at the center, you have mass number on top as an A, and then Z is the proton number or number of protons. The charge is on the upper right-hand corner, and we'll get into calculating charge in a moment. We can find the number of neutrons a certain atom has by taking the mass number, or A, and then subtracting the atomic number, Z, and that will equal the number of neutrons. The number of neutrons an atom has is not listed on the periodic table because each isotope has a different number of neutrons. I always like to add a couple of funnies in my slides here. An ion is an electrically charged atom. If an ion or an atom is neutral, then they will contain the same number of electrons as protons, and that's because the electrons are negative and the protons are positive. When an atom loses or gains an electron, then it will be left with a charge. Atoms can only gain or lose electrons. They cannot gain or lose protons or neutrons. When an atom loses an electron, it now has more protons, or at least one more proton than it does electrons, leaving it with a positive charge. And this is what we call a cation. When an atom gains one or more electrons, it now has one or more negatively charged particles and therefore overall has a negative charge. And this is what we call an anion. To help you remember cation versus anion, I have these two little pictures here. The cation is the positive one, and if you like cats, then you can think that cats will give you a positive or good feeling. And so you can remember that a cation is an atom with a positive charge. The word anion kind of looks like the word onion, and if you've ever cut up an onion, you'll know that it makes your eyes hurt or sting or water, cry, and that's negative or bad. So you can think of an anion as like an onion. Here's a sample problem. A neutral sodium atom has 11 protons and 11 electrons. If it loses one electron, what is its charge? So think about having 11 protons, and then if it is neutral, it's going to have 11 negative electrons. But then if it were to lose one negative electron, you now have one extra positive proton here that it doesn't get to cancel out. You can think of it as canceling out with a negative electron. Therefore, overall, the sodium atom here has a +1 charge. When a potassium atom loses an electron, how many electrons does it now have, and what is its charge? Potassium has the element symbol K on the periodic table, and when it is neutral, it has 19 protons and 19 electrons. When it loses one electron, it now has 18 electrons, and its charge would be a +1, for the same reason that the sodium was a +1 when it lost one electron. A sulfur atom gains 2 electrons and now has blank number of electrons and a charge of what? Well, a sulfur atom has 16 protons and 16 electrons when it is neutral. So when it gains 2 electrons, it will have 18 number of electrons, and the charge would be a -2 because it has 2 extra negative electrons that don't get to cancel out with any of the protons. Here's another example. Iodine is an essential trace element in our diet. It is needed to produce thyroid hormone. Insufficient iodine in the diet can lead to the development of a goiter, which is an enlargement of the thyroid gland. The addition of small amounts of iodine to table salt, iodized salt, has essentially eliminated this health concern in the United States, but as much as 40% of the world's population is still at risk for iodine deficiency. The iodine atoms are added as anions, and each has a -1 charge and a mass number of 127. Determine the numbers of each of the following: protons, neutrons, and electrons. Iodine has the element symbol I on the periodic table. If you find that element, you'll see that it has 53 protons just by looking at the periodic table. The number of electrons would be 1 more than the protons because of the -1 charge. There's 1 more negative particle than there are positive particles. The number of neutrons can be found by using the mass number, 127. If you look on the back of your periodic table, you can see that mass number is equal to protons plus neutrons. So if we take 127, the mass number, subtract the protons, we will get 74. So we have 74 neutrons here. There's our answers. An ion of platinum has a mass number of 195 and contains 74 electrons. How many protons and neutrons does it contain, and what is its charge? Pause to solve this problem. Looking at the periodic table, platinum has an element symbol of Pt, and it has 78 protons. Just by looking at the periodic table, you can find that number. We can see that the mass number is 195, so if we take 195 minus 78, the number of protons, we will be left with 117, and that's the neutrons. Because we have only 74 electrons, that means there are 4 more positive protons than there are electrons, which gives it the +4 charge. A lot of the element symbols on the periodic table come from the Latin name of the element. So for example, potassium, the Latin word for potassium is kalium, and that starts with a K, which is why the potassium symbol is a K.